Okay, guys. Today, which I believe is Wednesday, we are going to be doing a video on composite solids. Okay. Now, a composite solid is just when you take, we have three shapes we've been dealing with: cylinders, cones, and spheres, and I guess hemispheres as well. And we're going to put two or more of those shapes together and find the volume of the entire solid. Okay. So if you look on page 46, okay, that's where we're going to start. We're in this packet still, and we're on page 46. Circle that down here. Okay, we're going to look at example 1. Okay, we're going to skip around. We're not going to do very many problems today because it's not new information. It's just putting everything together. So here we have example 1, diameter of 10 centimeters. The height of the cylinder, which is this guy here, is 3 centimeters. And the height of the cone is 4 centimeters. Okay, so when we're doing this problem, we're going to take the volume of the cylinder plus the volume of the cone, which is on top. Okay, and we know the formula for the volume of a cylinder is volume equals pi r squared times height. And then we're going to have plus the volume of the cone, which is 1/3 pi r squared h. Okay, and now it's just a matter of plugging in our numbers. So if we're going to start with our cylinder, we have a radius. If this is 10, 10 divided by 2 equals 5. So we have a radius of 5. So volume equals pi 5 squared times the height, which is 3. Okay, so there's my first cylinder. Then we're going to have 1/3 pi. The radius is still up here. The radius is still 5, so we have 5 squared. And now we have the height of our cone, which is 4 centimeters. So we're going to take it times 4. Okay, let's see. 5 times 5 is 25. 25 times 3 is 75. So we have 75 pi here. Here we have 5 times 5 is 25, times 4 is 100, and then we have 100 over 3. So we have 100 over 3, and that's going to be pi. Okay? Now, I don't want you guys to get confused, but there's an easy way to get a common denominator. Okay? If we imagine that's over 1, we can find a common denominator of 3. So if I could find, I did have a pen here, and now I can't find it, of course. Let's see if I can get my other colored pen. Well, it's walked off on me somewhere. So let's just stick with green. We're going to multiply the top and bottom times 3 over 3. And what that's going to do is give me 225 over 3, and that's pi. Oh, thank you. Someone just brought me in, my husband just brought me in a red pen. Okay, so we multiplied that by 3 over 3. Okay, and then that's going to be plus 100 over 3 pi. Okay, and that's going to give us something nice. If we had 225 plus 100, we get 325 over 3 pi. Okay, so that is my exact volume, 325 over 3 pi. And you could try if you wanted. I can tell you right now that doesn't divide out nicely, so you leave it like that. But you could say 325 divided by 3. Nope, it gives you a decimal. We want exact, so you're going to leave it as a fraction. Then when we're doing our approximate, we put our little squiggly sign. We take 325 divided by 3, press enter, and then take that times pi. And you're going to get 340. It says round to the 100th place, so 0.34. See that? 34. And that is centimeters cubed. Centimeters cubed. Okay? And that's how you do volume of composite figures. It's not any different. It's just combining two shapes together. And in some cases, it might be subtracting, which I'll show you in a second. Okay, if you go ahead and if you turn the page to page 47, we're going to skip this one for now. Okay, I don't want to do too many problems today. We're going to start with example 3, and we're on page 47. Okay, so if you look at that, page 47. Okay, and here we have what? We have a cone. Find the rate. It says find the volume. Okay, so we have a cone on the bottom. Looks like an ice cream cone, right? And then on top, we have a half of a sphere, which is called a hemisphere. Okay, so we should know by now the volume of a cone. Whose volume equals 1/3 pi r squared times h. And then our volume for a sphere is 4/3 pi r cubed. But remember, this is a half of a sphere. or a hemi, so we're going to take it times 1/2, okay? And that's going to give me 4/6, which equals 2/3. So we actually get 2/3 pi r cubed, okay? So let's go ahead and plug in. Volume equals, for my cone, I'm at 1/3 pi. Here's the cone. Looks like my radius is 8. So I'm going to do 8 squared times my height. My height is 20, okay, times 20. Plus, we're going to have the volume of our hemisphere, which we said was 2/3 pi, same radius as 8, and that is cubed. Oopsie, it would help if you could see if I could move my paper up. Here we've got 8 times 8 is 64. Let's just put this in our calculator. We've got 64 times 20. It's going to give me 1280 over 3. 1280 over 3 pi. Plus, we've got 8 cubed. You should know that, but it's 512, okay? And then 512 times 2/3, we'll just say 512 times 2, which is 1024 over your 3, okay? And that's going to be pi again. We have a common denominator of 3, so we can add our numerators. We've got 1280 plus 1024, which is going to give me 2304 over 3 pi. Now, I can see, and I'm always going to test it. Maybe that's my exact, but if I can simplify that at all, I'm going to do it. 2304 divided by 3 gives me a nice even 768. So I'm going to say 768 pi. So my volume, my exact answer is volume equals 768 pi, and that is inches cubed, okay? Just take 268 times pi, and you're going to get 841. Did I do that right? 768 times pi? Oh, I keep wanting to do a 2, don't I? That's a 7. So sorry, 768 times pi, and that's going to give me 2412.7. The 100th spot looks like 0.74. And again, that's inches cubed, okay? So in that case, we had a cone and we had a hemisphere. We just added up the volumes and wrote our exact and our approximate, okay? One more problem. This is going to be a short video today. And I would like you to go to page, let's see. Let's go to page 50. Okay, page 50. You see, this is where I'm at. Okay, and this problem is tricky, okay? This is actually going to be a subtraction problem, not an addition problem. If you see here, you have 2 cones. You have the big cone, and you have that small cone. And if you picture it, it's like that small cone is a hole, okay? It's a hole inside the big cone. So you'd have to take the volume of the whole thing and then subtract out the volume of that little cone, okay? So we are going to do volume of big cone minus volume of little cone, okay? The big minus the little. So we know that the formula for the volume is volume equals 1/3 pi r squared times height, okay? And that's going to be for both. So I'm going to do my, let's just do our big cone, okay? So I'm going to do volume equals 1/3. Let's see, pi, my radius for my big, which goes all the way here, looks like it's 8. So you've got 8 squared times the height, and the height of the whole big one, you can see right here, is 12. So times 12, okay? And that's going to give me, let's see, 8 times 8 is 64. 64 times 12, and that's 768 equals 768 over 3 pi, okay? I think 768 is divisible by 3, and it is, and that gives me 256 pi, okay? So there's the big cone. Okay, now we're going to do our small cone. Change colors. Small cone, okay? Same volume formula because it's a cone. Volume equals 1/3 pi r squared times height. Okay, I'm going to take 1/3 pi. The radius of the small guy, that's this little hole here, is only, it looks like 4. So we're going to do, whoopsie, that's a pi. 4 squared. And the height of my little cone looks like a 6. Okay? So we're going to say times 6. Okay, so we have 4 squared, which is 16. 16 times 6 is giving me 96. And we have 96 over 3 pi. 96, we can tell right away, is divisible by 3. So we're going to get equals 32 pi. Okay? Now, we're not done. Remember what I said. This is as if it's carved out. Okay? There's a hole inside of it. So the volume of the whole cone, you're going to have to subtract out that little because it's a hole. So we're going to have volume equals 256 pi minus 32 pi, which is going to give me 224 pi. Okay, so my volume equals 224 pi, and that's inches cubed. Okay, now I'm going to take 224 times pi, and I get volume equals approximately 703.72 inches cubed. And there you have it. Okay, I stayed under 15 minutes today. We've got about, oh, you know what? I want to do one more thing. And it's not problems. I just want to go over what your homework is for tonight. Okay, it's going to be, let's see if I have these marked here. We're going to have a few problems here. It looks like you're going to be doing page 48. You're going to be doing this guy right here, which is just the addition of you're going to add 2 different cones. Okay, that's the first one. I think you're going to be doing this right here, which be careful because you're going to be adding a cylinder and 2 hemispheres. And you can say, you could either take the cylinder plus the hemisphere plus the hemisphere. I think I said cone, sorry, it's a cylinder. Or you could take a cylinder times 1 hemisphere or 1 sphere because 2 hemis add up to a sphere. Okay, so be careful on that one. I think you also have to do, let's see, page 51. You're going to be doing these 2 problems here. Be careful on this one. This is a cylinder minus the sphere, or this, let's see, cylinder minus the cone, which is inside, because you can see that's like carved out there. So be careful with that one. Number 8, you're going to do a cylinder plus 2 cones, okay? And finally, your last problem, I believe, is this one right here. And this is, again, super tricky. It looks like that hemisphere is carved out of the cone. So it's going to be a cone minus a hemisphere, okay? So be careful when you do those. I just wanted to give you a little heads up on how to do those problems in case they're tripping you up tonight, okay? That's it for today.